10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hi again, everyone, and welcome to our second keynote featuring Forrester's senior analyst, Erik Nost. Erik will be sharing from his recent report, Strengthening Proactive Security with Continuous Security Testing, explaining why and how continuous testing is becoming essential to proactive security. And don't worry if you haven't had a chance to read the report yet, every participant will receive a complimentary copy at the end of the event. Erik, take it away.
Hello. Thank you so much for having me here at Exposures 2025. I'm excited to talk to you all today about proactive security programs, particularly exposure management and continuous security testing, because they often kind of get lumped together into the same category, but you're actually going to achieve very different outcomes from each one. So I'm going to talk to you about that. I want to make sure you have a takeaway around identifying when you're ready to start continuous security testing, and also what your key considerations will be for implementing these more modern prioritization strategies. So first, real quick about me. My name is Erik Nost. I am a senior analyst at Forrester Research, where I cover attack surface management, exposure management, vulnerability management, and really everything that makes up a proactive security program at the end of the day. I live in Massachusetts with my wife and my 3 kids, and I'm actually a very proud New Englander. So yes, I encourage you to visit New England. You could, of course, drive around aimlessly. It's more likely you would plan your route ahead of time. So say you want to check out one of the fantastic harbor towns in Maine. Well, the thing to know about the harbor towns in Maine is they're segmented off the highway, and they're kind of in their own little peninsulas along the coast. So you would need to assess your route and know that right path to get there. And this is why in Maine, we have a saying, you can't get there from here. And this saying, it's ultimately what we're trying to validate when we're building out our proactive security program, whether or not our organizational crown jewels are accessible or protected from the bad actors. But how do we assess and validate whether bad actors can get there from here? You need a starting point. It's always going to be visibility. This is the first principle of your proactive security program, because you need to know what you know, and you also need to understand what you don't know. And there's 2 important considerations when you're assessing the types of visibility you have. The first is breadth. You need to have good perspective around all the stuff in your environment that needs protection, from data, networks, workloads, IoT, and many of these are going to fall under your program scope. And even if they don't, they can still impact your ability or your inability to be proactive. The second's depth. So there's breadth and depth. And for depth, you want to understand all the characteristics surrounding the assets that you're trying to protect as possible. So things like, what's this asset for? Who uses it? What business processes does it support? And these are going to be crucial, breadth and depth, to understanding your environment, which is going to help you fine-tune your prioritization strategy. Your prioritization strategy today, it likely has a whole bunch of inputs that go into it. I mean, there's findings from quarterly application penetration tests, compliance audits, red team assessments, and so on. And I know you all have risk scores everywhere. You have dozens of security solutions you've onboarded. They all have their own risk score that's like 1,000 or 100 or A, B, C, D. So to take better control around our prioritization strategy, it starts with that visibility step, so we can take those insights, including the depth, like context, like asset importance, control, presence, and so on, to build this modern prioritization strategy. And this is what we're talking about when we're talking about exposure management. We're talking about taking these insights and mapping them all together so we can graph threats and understand how they can impact your environment, whether compensated controls are theoretically in place or not, and what the likelihood of those said threats are. So exposure management, it gives you an assessment, but that map doesn't tell you whether a road is accessible. It doesn't account for potential roadblocks or detours. You need to actually drive that road to know how accessible it is or not. And that's how you get validation. And this is how we've implemented security testing over time, both traditional pen tests and red teams, but also continuous security testing and how they can both complement your exposure management prioritization strategy. It proves that assets are going to be reachable when vulnerabilities are exploitable, when they shouldn't be. So what that would look like is something like this. You start with a visibility in your crown jewel assessment. It gives you insights into the inventory that you have, but also what you have protecting assets and what is missing. So things like, is your crown jewel accessible from the internet? And do you have the proper detection tools on it for if it's improperly accessed? Do you have redundancy and backups, both in like the asset itself, but also the control environment that's protecting that asset within that backup environment? And from there, that's when you can start to test and validate these attack paths and the exposures you have. Once you know what you have to protect and what is protecting it. And this is what we're talking about with exposure management. Now, we define exposure management at Forrester as a platform approach that really consolidates vulnerabilities and weaknesses. And what's crucial there is understanding, we mean CVE vulnerabilities, so vulnerabilities that have a CVE assigned, but also problems around misconfiguration. So, publicly exposed S3 bucket or, overprivileged identities and so on. And that's crucial to really build this attack math and understand what the organizational perspective is around what could it potentially be accessible. What we also see is the accumulation of attack surface management feeding into exposure management, both from an external view and a CASM view. So there was an external attack surface management, EASM, that does external scanning of assets that could be attributed to your organization. That gives you kind of that attacker view. But to build this attack path, you also want that internal view around what defenders see, what controls are protecting it, and that asset context that we talked so much about already. So these are features that you should look for within exposure management solutions as well. Then ultimately, you tie that all together. It gives you an attack path and then lets you know, here is the choke point you might want to focus on because it's going to remediate that biggest blast radius of what could potentially happen. So from a practical implementation standpoint, this is what it would look like. You have a crown jewel assessment, and within that visibility step, you confirm that controls protecting your assets are at minimum present. You want to know that they're there. And as you're assessing those exposures, it comes down to things like whether workloads and people, devices can access that asset and the vulnerabilities that enable access when that asset should not have access to it. And that could come through anything like from a phishing email, from a CV on an endpoint that's going to allow privilege escalation or improperly provisioned workload. And then you can model threats using this attack graph to ask yourself questions like, if this identity accessed a sensitive asset, do we have proper detection controls on that asset? So will we be alerted? If this workload accessed data that we thought has been segmented, would there be controls down the line that would let us know that there was improper access as well? So this is what we're talking about. We're talking about exposure management and proactive security programs, knowing what you have and knowing the exposures that can lead an adversary to that point, which comes from visibility and identifying those routes that could take. But just like our trip to New England earlier, this is an assessment. This is telling us whether or not a path is theoretically in place or not. To know whether or not it's truly accessible, you need to get in your car and you need to drive that route to experience all the detours and bumps in the road and so on. You need to physically take that route. And it's a lot like, how football teams, they plan for the big game. They'll assess and they'll draw up their potential plays, but they don't know whether their offensive or defensive schemes are any good until they put it to the test. And there's ways to kind of emulate that and plan for that before the game, which we also do today within our traditional point-in-time security assessment tests. So we've done penetration testing, right? Those are narrow in scope, understanding whether there are vulnerabilities that might be present within like a web application is kind of the classic example. And that's a lot like how, a football team, a football coach might look to see if they can run the ball up the middle versus, a red team objective, a red team engagement. It's much more objective driven. Can we achieve an outcome based on the activities that the red team is going to conduct? And from a playbook perspective, it goes beyond just, a play that you might run to an outcome like, well, this offensive scheme allow us to score a touchdown, or, well, this defensive package let us stop, an elite receiver, and so on. And then there's also scrimmages. And that's really, at the end of the day, kind of what purple teams are like, right? It's taking your offensive units, you're taking your defensive units within the same team, with ultimately the same goal, and putting them together to kind of validate what the playbooks are like. But they don't account for the other team's playbooks. One notable thing about these point-in-time tests is also they're all human-led, and they're also point-in-time static assessments. So these strategies are having a harder time keeping up with how we see organizations deploying modern technology environments. Because in today's digital landscape, IT, it's not one size fits all. Most organizations have various different styles that they're supporting their business with as part of their technology deployment. So we break it down to Forrester to 4 different styles. The first being the enabling style. And this is kind of like the bedrock classic IT, teams that are focused on operational excellence and uptime, reducing costs, and most likely associated with that traditional on-prem data center type technology deployments. And that's really what's going to be better tuned towards these point-in-time static tests that we're doing. They're more predictable. But a lot of organizations are also doing a co-creating style. And these teams are all about speed, innovation, working hand in hand with the business to deliver new products and experience. And this is DevOps, guys. We're talking about DevSecOps and deploying and making changes much faster than ever, which is a challenge for point-in-time assessments because those changes are happening so much more quickly. It makes these point-in-time assessments that we spend months sometimes scoping out quickly irrelevant when your environment's changing, that frequently. A lot of organizations also emulate the amplifying style, and this is all about innovation, using AI and automation analytics to really drive efficiency for better outcomes. But at the end of the day, there's just so many inputs into what's happening within these environments. It makes scoping these much more difficult. So there's so many inputs to consider as you're thinking about how you're going to conduct your red team exercise for that. And finally, there's the transforming style. So this is about bold tech-led innovation where teams are embracing emerging technologies, AI and digital twins. And for security teams, this is challenging because, security needs to be a business partner, but we also need to assess, whether or not these attack paths we talked about are accessible. But transforming styles are innovating at speed and scale, which makes static point-in-time assessments that much more difficult to keep up with. And this is why continuous becomes that much more necessary in today's world. Now, there are 4 types of continuous security testing, which I want to make sure everybody's aware of. Now, we expect the kind of the accumulation of some of these capabilities in the near future. But as of today, we see BAS, breach and attack simulation, a PTAS, penetration testing as a service, bug bounty, and automated exploit testing as their own kind of independent functions. But on the horizon, look for vendors kind of combine these capabilities. So kind of break down what to get out of each of these today. BAS is going to emulate real-world attacks to specifically validate the effectiveness of your detective controls. So it's going to look at, your EDR and your SIM and detection engineering practices to help you validate whether your detection stack is actually catching what you think it should. These are technology-led solutions that are just constantly probing your defenses and giving you inputs on detection engineering. Penetration testing as a service, PTAS, that's going to bring rigor of traditional pen testing to an on-demand / continuous model. It offloads those routine tasks that your in-house red team and pen test teams are doing to help kind of augment discovery and reporting, providing, project management tools as well, and gives access to human pen testers when you want to give them access to something, specific scope of a pen test within your environment. We also have bug bounty. So bug bounty programs are crowdsourced security, which is inviting ethical hackers to find vulnerabilities in externally facing assets. So they're typically, very focused on web apps, but they'll use, broader, diverse talent pools to uncover those edge case kind of vulnerabilities that your automated tools might have missed, especially, again, in web applications. The last that we see is automated exploit testing. So automated exploit testing continuously runs known exploits in your environment to complement your vulnerability management program and tell you whether those vulnerabilities are actually exploitable. And it's technology-led. It usually is deployed via agents or sensors within your environment and really helps you to prioritize and validate what needs fixing. So each of these methods, again, they play a unique role in a layered defense strategy you're going to have. We expect more of these to come together, particularly around the accumulation of scope and use case and methodology. So look for vendors that will provide scope outside of just like a web app, and also test for things beyond just like detective controls, things like also identifying and validating exposures. Again, kind of accumulating within one experience within the marketplace. So this all probably sounds a little familiar, right? We're going from like a static project-based, implementations for security assessments to something that's more continuous. We've been here, right? We've gone through the Phoenix Project and the DevOps Handbook. We've tried these agile implementations before. And there is a lot of parallels here. If you're looking at waterfalls, SDLC, Secure Development Lifecycle, they took planning, it took scoping, it took kind of, iterative process to kind of move along, just like how you scope and plan a red team exercise or a pen test around specific objectives and stages and approvals and everything else. We're talking about getting to something more continuous here. So if pen testing is waterfall, continuous security testing is really looking at, an agile type style of how you've been doing this. But, the Phoenix Project, DevOps Handbook, and these other, literatures, they came out like a decade ago now, right? And we're still having problems implementing agile. I haven't talked to any organization that thinks that their agile implementation is cream of the crop perfect so far. And we see this as well in our Forrester surveys. So when we ask developers what their challenges are around agile implementations, if you look at the stuff that is kind of highlighted in green here, you can see that there's actually themes around people and culture and skill set, right? So if pen testing is waterfall, and continuous security testing is agile, let's learn from our agile implementations that we've done so far and apply what's worked and what hasn't worked. And there's going to be, different variations across what's worked and what hasn't worked for your organization. So take those lessons, but then also borrow principles from Kanban or Scrum or whatever your preferred methodology is towards your continuous security testing. So let's look at an example of how you can apply Kanban to continuous security testing. So first is visualization. Visualization is absolutely crucial and keeping, Kanban alive here. Lets everyone know the status of your tests and lets the stakeholders who've delegated trust to, the subject matter experts, to understand what the status is as initiatives in the testing move along from, backlog to to-do to done and so on. Because those doers must be the ones that influence what needs to be done. So you do need to let go and trust your experts. And that includes trusting your red teamers and your SOC and your DevOps teams to scope and to execute these tests. These are giving control back to the folks that are doing the work. Another important principle is to kind of think about setting limits to works in progress. You don't want to do too much at once. And it's prudent to set limits to the number and types of tests being done at once as well, which also means you need to establish rules. You need to know when you can move a test from backlog to to-do, to doing, to done, and what the rules are for, making these tests blockers as well. So establish all of those as you implement and iterate on your continuous security testing program. Consider characteristics like who's going to be notified, what remediation owner is going to be responsible for fixing any findings that we find before moving these along to what statuses that you determine as well. Also make sure that you're thinking about the flow. So how are you going to groom those priorities, which means partnering with the business and having a responsible party for who's choosing the to-do next, with solicitation from those subject matter experts that you're then delegating to do and run and execute these tests in a very continuous nature. And another thing, just quickly, is collaboration and feedback. They're going to go hand in hand. I don't think you need to have a 4-hour retrospective every Friday around how your continuous security testing is going, but you do need to take the time to acknowledge the tests that have been done, and congratulate teams on a job well done and so on, but also discuss any blockers that came up during tests and whether those rules around managing flow might need to be modified, iteratively based on how your continuous security testing program is moving. So to get started, building a continuous security testing program, first take a look at your current workflow and processes and ask yourself what's working well and what's not working so well. Because, maybe you have a pen test team that's, very good at finding SQL injection vulnerabilities, and they're already automating things with Burp or SQL Map or so on. And if it's being automated already, there's no need necessarily to offload that into a continuous security testing provider. Instead, look for methods or tests that your internal teams are yet to master, right? Likewise, if the team has strong processes around things like reviewing findings or existing ITSM workflows, leverage those. Ensure that you're using the internal processes and workflows that are working. And if there's room for improvement, look to see if continuous security testing providers or / your implementation can help improve where there's gaps. Also, respect current processes and roles and responsibilities. Don't step on folks' toes. Maybe within your organization, someone else is responsible for ordering a security assessment. Maybe a product owner is required to run a security assessment before going to production or so on. Don't bombard that team with security assessments if there's no need to do so. Know what the guardrails are and know who's doing what essentially within your organization. Also, agree to pursue incremental change over time. Continuous security testing, it's going to find a lot of issues, and it can be overwhelming if you do too much too fast. So think about a crawl, walk, run approach here. It's naturally going to be best as a way to kind of set expectations and know how the testing will look and how you can eventually kind of scale it. One thing I tell folks is, look to get around 80% or better of your initial findings remediated before you start scoping out more tests, because what's crucial is you really don't want to bombard teams with more and more issues. It's going to erode trust in what you're doing, and accountability for the teams that are just having way too many issues that are being thrown at them. So think about how you're going to make changes incrementally over time. Last, kind of going back to our principles around Kanban on, allowing folks to take control of the work. Within that, encourage acts of leadership at all levels. So use work in progress, open statuses, ownership assignment to allow folks to have autonomy in what they're doing. And then with that, you also have guardrails to encourage the right collaboration. So know those roles and responsibilities to build this culture of continuous iteration, continuous improvement, and continuous accountability. So just a couple other things before we wrap up here around things to consider for continuous security testing. One has to do with the types of findings that you're going to encounter, because continuous security testing, they're going to give you findings like, hey, there's a patch that needs to get deployed over here. You can ship that off to whoever needs to deploy the patch. But it's also going to have findings that really have a root cause that are foundational towards your code repo, or it might require you to do a whole .NET or Java upgrade and so on. So you want to track those, but you want to track those in their own separate projects. And there's kind of two schools of thought that I see folks doing about what to do with the new findings that come up with these project-based findings. And there's kind of pros and cons to each. One is just auto-close them and track them in that project. But that doesn't necessarily keep letting folks know that, hey, there's a problem that keeps continuously being found from our continuous security testing solutions. The second is leave them as open, put them in the project. And some folks can keep that, as a solicitation to buy-in that, hey, we need resources to be able to fix this project-based finding because our continuous security testing solution, hey, it keeps on finding it, right? But again, the con of that's going to be too many findings, eroding trust and so on. So really two different approaches there that I see organizations take. Another is going full circle back and using continuous security testing to validate when remediations are done. So most continuous security testing solutions will do that. So once an exposure is assessed, continuous security testing validates it. You find the remediation owner, they fix it, have a workflow that goes back into continuous security testing to validate that the remediation that owner took place did indeed fix the finding. Because that's a feature that continuous security testing solutions also frequently have. Last but not least, visibility here is a prerequisite. You need to have adequate knowledge of what you're testing to begin with. What are the controls that need to be tested? What are the crown jewels? And know what the expected outcomes are and how these controls should be operating. Otherwise, you're just running these things in isolation without having a good understanding of what they should be doing. So I want to leave you all back to my favorite athlete of all time, the greatest quarterback of all time, the GOAT, Tom Brady. And I know that's not just my New England bias speaking, but I'm sure you've all heard, the story of how Tom Brady, he went 6th round in the 2000 NFL draft. So all these other teams, they sat on Tom Brady, they slept on him because their assessment of what he was capable of was initially wrong. They had to put him to the test to validate him continuously over and over and over his illustrious career, playing the toughest teams because he was always in the playoffs every single year. And this is how Brady cemented that status as the GOAT. So don't assume your assessments are correct. You need to put them to the test continuously, iteratively, and prove your organization is putting up and keeping up with evolving techniques and new threats and the constant changes in your environment, just like Brady had to deal with dozens of iterations of rival teams and different teams between the Bucs and the Patriots, different team dynamics and inflated and deflated footballs. Nobody thought, Tom Brady could get to the GOAT status from where he started at the Combine. So it might be overwhelming thinking about how you're going to improve your product security program. When you feel overwhelmed, just think back to how Tom Brady felt as he kept being passed over in the 2000 NFL draft, because that assessment initially failed. There's still opportunity for you to cement yourself as the greatest of all time. So again, thank you so much. I hope you enjoy the rest of the day here at Exposures 2025. Looks like we have a really great lineup, and thank you for your time.
Thanks again to Erik and Jen. Your sessions were not only inspiring, but also packed with practical advice. I'm sure our audience at home feels the same way. That wraps up part 1 of our day. Now we're moving into 2 parallel tracks, and you, our attendees, can choose which sessions to join just like before. All you need to do is scroll down to the upcoming sessions section on your screen and click Join Session for the one you'd like to attend. When that session ends, feel free to select your next session the same way. And don't worry, if you're interested in more than 2 sessions, we've got you covered. A recording of any session you missed will be sent to you at the end of the day. Remember, you're free to move between sessions. You're not locked into one track. So jump in now to your chosen track by clicking Join Session. A short commercial break, and we'll begin.